So we want to find the Laplace transform of f of t equals cosine 5t plus 4e to 3t minus 9t cubed. We will use the linearity property of the Laplace transform. So taking the Laplace transform of these three terms will be the same thing as finding the Laplace transform of each individual term and then factoring out the constants. So we have the Laplace transform of cosine of 5t plus 4 times Laplace transform of e to 3t minus 9 times Laplace transform of t cubed. And now we can use these formulas to help us solve it. So if I have the Laplace transform of cosine bt, that's going to be s over s squared plus b squared. Laplace transform of e to the at is just 1 over s minus a, and Laplace transform of t to the n is n factorial all over s to the n plus 1 power, for n is equal to 0, 1, 2, etc. So now let's focus on Laplace transform of cosine 5t. B here is 5, so that's going to be s over s squared plus 5 squared, simplifying to s over s squared plus 25. 4 times the Laplace transform of e to 3t. Here a is 3, so that's 1 over s minus 3, multiplied by 4 to get 4 over s minus 3. And then finally, we have negative 9 times the Laplace transform of t cubed. Here, n is equal to 3, so it's negative 9 times 3 factorial over s to the 3 plus 1 power, which simplifies to negative 54 over s to the 4th. Finally, we can combine the solutions and get s over s squared plus 25 plus 4 over s minus 3 minus 54 over s to the 4th as our final answer.